Let's tie it all together with section 5.2. And we're going to find probabilities for normally distributed variables. So we're going to actually do, like this is kind of the end game for normal distribution, is being able to find probability of an event occurring if you can assume that that event is approximately normally distributed, right? All of the possible ways that that event could happen, right? So, if it's normally distributed, you can find a probability. That probability is the same as the areas we've been finding, okay? Same thing. Those areas that we've been finding, they actually correspond to probabilities. So we'll be able to, based on some x value, be able to plug that into a formula, get a z-score, and then you guys know how to find the area given a z-score, right? So like I was saying, we're going to tie it all together. So remember with our standard normal distribution? No. What we're going to do is we're going to plug a value. So for instance, right, if I had an x value over here on the left-hand side, I've got an x value of 600. If I plug that into the formula that we looked at, and I believe it was 2.4, where you guys calculated a z-score, right? So this formula, we'll plug the x value in with the x. We'll plug in our mean, which is 500, where mu is, and our standard deviation of 100, where sigma is. If you calculate that, you get 1. It turns out that if you look at your normal distribution and your standard normal distribution, you got the same area. So we're going to tie that all together. All right, let's do it. Let's do a problem. All right. So in this problem, the average speed of vehicles traveling on a stretch of highway is 67 miles per hour with a standard deviation of 3.5 miles per hour. First thing I'm going to do, they just told me my mean, or mu, is 67. What did they also tell me? My standard deviation, or sigma, is 3.5. They're saying, hey, if you were to just randomly pick a vehicle, see how fast they're going, what's the probability that they're going 70 miles per hour or above? Well, what's the probability that they're going over the speed limit? All right, so we're going to assume that the speeds are normally distributed. This is important, by the way, also. That should always be capitalized. It's so that it doesn't, the reason why it's capitalized is so that we're not, so we know that you're talking about like the normal distribution property, not it's normal, like not irregular. So it's supposed to always be. So what are we going to do? How are we going to solve this? Okay, what you're wanting, essentially, if we look at a picture of our normal distribution, not the standard normal distribution, but our normal distribution, this picture looks like this. The mean is 67, right? What we need to do is find that shaded region. Okay? What we're looking for is the area of that shaded region. The area of that shaded region is the same as the probability, oh, my bad, violating, dang it. If they're violating the speed limit, they're going above 70 miles per hour, not below, right? So then we're actually looking at that shaded region. Apologies. All right. Okay. So what we're going to do is we're going to get a standardized value for this, right? In other words, we're going to get a z-score. How do we get a z-score? We do x minus mu divided by sigma Okay? What is our x value? It's 70. Our mean? 67. Standard deviation? 3.5. I'm going to put that in my handy dandy calculator. Okay. 70 minus 67. Yeah, 0.857? You are correct. Approximately. It's approximately 0.857. Okay, so what does that mean? So if I was to look at a standardized value, right, what we've been looking at before, what that's going to look like, remember zero's in the middle, right? So 0.857 is going to be what, like somewhere around here, 0.857. Should be the same area, right? Unfortunately, I'm not that good at drawing, so it doesn't look exactly. But it is. It's going to be the same area. So when we find this area, we have found that area too. So we can find this area by going to our table of values, right? Looking for a z-score of 0.857, 0.8486, right? 0.86, we'll round that, right? Yep, 8051. So I'm going to write some notation here. What we're looking at is the probability that x is greater than 7. Okay? That is the same thing as the probability that z is greater than 0.857. That's equal to whatever you find on your z table, which we said was 0.8051. Okay? This right here, ladies and gentlemen, is your answer. So the probability that someone is going 70 miles per hour or faster is 0.8051. So in other words, if we were to put it in context and think about it, right? On this stretch of highway, if you were to just randomly select a car, if you were to put a speed gun, right, on the car, the probability that you catch a speeder is about 80%, about 81%, if we're around, right? That's kind of putting it back in time. So that's the kind of stuff we're discovering. And this is really stuff that is done all day, every day in the world. This is really actually super useful and super relevant now. Yeah.
So you wouldn't just find 0.857 on here and see where that next to. I got a low. As soon as you got to this,
Okay, let me show you where we got this from the table. And I'm also going to give you an alternative way of doing it too. On my z table, I am looking for 0.8. Right, so we have what, 0.86, okay? So we round it. So we're looking at, so we go to 0.8 there, and then 6. That's 0.86, and there's the value that matters. So that's where it came. All right, I'm going to show you guys how to make your calculator do this as well. So that we have two approaches. So this first one, I'm doing a lot of stuff. You don't have to do all this stuff to do a problem. You can pick one or the other, and that's what we'll do from after this problem on. Okay, so another approach If you get out your handy dandy calculator, and you can do this from just your scratch pad. So you can hit this, you can hit the calculator button, do it from your scratch pad. You don't have to insert a list in spreadsheet, you don't have to do all that stuff, okay? It's much simpler. All you gotta do is hit menu, probability. We're gonna go to distributions just like we've done before, right? When we're calculating binomial distributions and geometric distributions. Now we're gonna look at a normal distribution. What we're gonna choose is normal CDF. Alright? So, you got to choose what your lower bound and your upper bound is. So, from where to where, right? So, in this case, our picture went from 70 all the way to infinity, right? We went 70 to infinity. If we wanted to know less than 70, we would go from 70 to negative infinity. But in this case, we're going from 70 to infinity. So, our lower bound is 70. Now, your calculator doesn't understand infinity, right? So we'll put in a number as close to infinity as your calculator can handle. So most calculators can handle 10 to the 99th power. That's pretty good. We'll enter the mean from the problem, which was 67. And the standard deviation from the problem, which was 3.5. We go down and hit OK, and it gives us the answer. Did I get numbers wrong?
Maybe so you can see that.
Did I put what?
Did you need to put CDF or PDF? Did you put CDF?
No, it should be CDF. 67. Did I put some numbers in wrong? Let's look again. What in the world happened? We were looking from 70, right? Oh, no. Who's that? Maybe one of our other calculations is on. Because I don't imagine we're going to get a different number. Okay, let's look back at what we did before. I must have made some error. 70 minus 67 divided by 3.5. Sorry, I'm a little slow this morning, I guess, right? Dang it. So, it's okay. Everybody makes mistakes. So this number is not actually the answer, right? I made an error that's really common that my students make and I tell them not to make, and then what did I do? I made a mistake. What is this? This, what I just found here, is not the probability that z is greater than. It's what I just found was the shaded region to the left, not to the right, right? Remember what you got to do? You got to subtract it from 1 in order to get the shaded area to the left. Wow. You're shaded. 8051, which turns out to be 0.1949. Wow, my bad. Alright, so this is the first way to do it. So the second way to do it was using our calculator. Second. That's the answer. So here's the second. The calculator is going to be slightly different, but it's not that far. If you were around, it's not that far off. So the first way to do it, we did it by hand. The second way is the calculator way. I'm going to show you what your answer, the way that you should look like when you answer it. So if you're going to do it using a z table, this is the correct way to approach it. Okay, this is the work that you need to show. If you're going to do it using a calculator, you have to say that your mean is 67, standard deviation is 3.5. You have to show that you actually did your 70 minus 67 divided by 3.5. So you've got to get this value, this 0.857. And then you've also got to show a picture. You can show the standard picture, or you can show the normal distribution picture. I like to show the normal distribution picture. And then rather than doing all that probability stuff and all of that, what you can do is you can say your answer is normal CDF, and you put your lower, upper, mean, standard deviation, and you can say that this is equal to, or you can put it right at the end, whatever you want. But that is equal to the desired probability, which is approximately 0.196. Approximately 0.196. Okay? So 2 ways to do it. Using your table of values and using your calculator. I highly recommend you do the calculator. But don't do the calculator without drawing the picture, because you have a higher tendency of getting it wrong. I'm doing what I just did. So let's try another. Ready? It is. I'm going to encourage you guys to go on the calculator. So this next one, I'm going to do on the calculator. So each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store, guys. The length of time spent at the store are normally distributed. What is the probability that a shopper will be in the supermarket between 33 and 60 minutes? So first thing, they told me average, which is our mean. They told me standard deviation was 12. What's a picture of what we're looking for? If we look at the standard picture, that is between, so 45 is in the middle, 33 here, and we've got this value right here, 60. So what are we trying to find? This shaded region. All right, cool thing about the calculator is now that I have identified the shaded region, I can just straight up go into the calculator. All right? And state my answer. This is the most efficient way to answer this question. So I go to my calculator, I hit menu. That's right. Probability distribution, we're going to go normal CDF. Now our lower bound was, what did you say? 33? Upper bound, 60. Mean was 45, standard deviation 12, right? We hit OK. Boom, it cranks it out. All I have to do to show my work for this particular problem is write normal CDF, 33, 60, 45, 12, and my answer. Okay? You also have to show the shaded region that I showed. So what I'm giving you is all of the work, everything you need to show for your answer. I mean, and this is a sufficient answer for an AP course as well. So I mean, it is golden, all right?
Including the standard distribution or no? When you plug it in.
What do you mean?
The normal CDF?
Yeah, normal CDF.
Yeah, okay, so there's a lower bound, upper bound.
Yeah, so your lower bound is, so I'll write it down for you, normal CDF, it always goes. Lower bound, 33, comma, upper bound, 45, comma, oh, my bad, upper bound is 60. Standard deviation, 45, my bad, mean, comma, standard deviation, getting ahead of myself, boom. Then you can just say that is equal to, what is it, approximately 0.736. Approximately 0.736. That is a complete answer. And this answer would be, again, it would be accepted on the AP exam. So it is easy, it's quick, and it's nice. So yeah, I put the standard deviation from the last problem. Should be, well, cool, thank you. All right, let's do another one. Triglycerides are fat. All right. Talking about how fat Americans are. Okay, we're happy. So I see mean right away. As soon as I see mean, I'll write that bad boy down. Right? Those are normally distributed. You got a standard deviation of 35. So they select someone at random. We want to know what the probability that their triglyceride level is between 100 and 150. We don't have the lower end again. So what does that look like in my picture? In the middle we got 134. Over here we got 100. And over here we got 150. So we're looking for the area of this shaded region. Already calculated. All right, so we're going to go to our calculators. And we'll choose menu, statistics, distributions, normal CDF, and in there we'll put a lower bound of 100. We'll put an upper bound of 150. We'll put a mean of 134 and a standard deviation of 35. 0.510. You rounded it? And it is approximate, so we have these things. Yeah. I'll go ahead and put that into the calculator for you so that you can see it one more time. So how would I do that? I would go maybe statistics, distributions, normal CDF, lower bound was 100, upper bound 150, mean 145, 134. Dang. Standard deviation was 35. That's right. And there it is. Okay, I am actually going to go ahead and add on to this problem because there's something noticeably missing. What is the probability that their triglyceride level is below 100? Okay? Yeah, so what is the probability? The triglyceride, we're just going to abbreviate level is below 100. Okay, so we're going to add on to that. Yes?
Maybe 49 is above.
That's between 100 and 150. Right? If it was strictly above, you would be absolutely correct, right? You could just subtract from 1 and get it. But what we're looking at is this picture. The mean was 134. So 100 is somewhere down here. And we're looking for this area, right? So how do we put that in our calculator? That's right. You need the lower to be negative infinity, right? So we're going to go menu, probability, distributions, normal CDF, and now it's already there. So it goes -9 e to the, so it's already there. That one's already there for you. You could use -10 to the 99th power. It'll give you the same calculation. But it's already there, so it's nice. Your calculator will automatically always put that there. What in the world do you do? And let's get that part of the board too much. Our upper bound is 100. Mean we said was 134. Standard deviation was 35. And we get a probability of approximately 0.166. So how would we write down our answer? Just like this. Just write down what you have on your calculator, normal CDF. I'll just write 10 to the 99, negative, right? 10 to the 99 is our lower bound. You can just write exactly what's in the calculator. Just remember that E thing in your calculator is saying times 10 to the 99, okay? Our upper bound was 100, mean of 134, standard deviation 35, and that was equal to, what did we get? 0.16, approximately 0.1. Thank you. Okay. I'm going to rush you the whole way. Okay. That is everything that you need to complete this assignment that we'll start working on tomorrow.